So, this question that appeared very recently in 2020, it says the amount of solar energy received on the Earth's surface per unit area per unit time. This quantity it is defined as solar constant. So we have this quantity, solar constant. Let me call that as K, okay, since this is a constant, solar constant. This is defined as energy received by Earth, energy received by Earth per unit area per unit time. That means time is also in denominator. This is how we define the solar constant. And the question is asking what is the dimension of this solar constant. So first, we'll need to find the dimension of energy. Then we'll need to find the dimension of area. We'll need to find the dimension of time or the dimensional formula of these three quantities. Substitute that and simplify. That's how we get the answer. So what is the dimensional formula of energy? Well, the dimensional formula of energy is same as the dimensional formula of work done. And work done, we all know, is force into displacement, right? So force into length. I've started putting in symbols now. Area, how would you write the dimensional formula of area? Area of anything is length multiplied by length. So if we are calculating the area of a square, it's length into length or side length into side length. So that's basically L square. Area of a circle also, you'll see R square is there, right? So L square will be there. So that's the dimensional formula of area. What is the dimensional formula for time? T. That's all. Almost 80% of my work is done. If I'm able to find out the dimensional formula of force, I will have my answer. Well, force is given by mass into acceleration. So mass into acceleration. Didn't we see the formula for acceleration just a while back? It was LT minus 2. This was the dimensional formula for acceleration. And then this L I'm going to write here once more and all the other things in the denominator. L square here, T here. When we simplify this mass we can write as M and then we can simplify. So if we simplify what we'll get, there is 1 M in the numerator, no M anywhere else. So mass to the power 1. So L to the power 2 here, and in the denominator also there is L to the power 2. So 2 minus 2, L to the power 0 is what we will get. What about T? T to the power minus 2 in the numerator, and there is 1 in the denominator also. So minus 1. So this is what we'll get. ML0 T minus 3. Which option is this? ML0 T minus 3. It's option number B. So that's our answer. Okay, simple. Okay, we have one more question. Let's solve this one. So, time t, velocity c, and angular momentum h are chosen as fundamental quantities instead of mass, length, and time. All right. In terms of these new fundamental quantities, we have to express the dimension of mass. Interesting. So yes, we will have to relate mass to these three quantities. How can we do that? Mass and velocity, are they related? I don't see a direct relation because the unit of velocity is meter per second. There is no mass there. So we can't directly relate velocity and mass. We can't directly relate mass and time also. So let's try to relate angular momentum relate angular momentum to mass? Well, we know how angular momentum is related to linear momentum, don't we? We know that angular momentum is given by r cross p, where p is the linear momentum and r is the radius vector. P, which is the linear momentum, has mass in it, isn't it? So mass into velocity gives you, so radius into mass into velocity. Let's write the dimension of this. Now, h is a fundamental quantity according to the new system. So we'll keep h as it is because we need fundamental quantities. Mass is what we have to find out. So we'll keep mass also. Radius, velocity, and mass. Is velocity a fundamental quantity according to the new system? You see, velocity is also a fundamental quantity according to the new system, and its symbol in this new system is c. So we'll write h is equal to r, which is the radius vector, c times mass, or mass will become h upon r times c. But r is not a fundamental quantity. R, that means distance, is not a fundamental quantity. We need to eliminate this thing from here. Instead, if I can get seconds or velocity there, I'll be good. To eliminate r, we use another trick. Distance by time is velocity, yes or no? And velocity is a fundamental quantity represented by c here. So distance can be represented as distance vector or radius vector, which is also a distance vector, can be represented by c into time. Yes or no? Yeah, c into time. So this r can be written as ct. I hope you agree. So what we will have is h upon ct times c. Now from here we can get the dimensional formula of mass in terms of h, c and t. Mass is equal to h to the power 1, c to the power minus 2 and t to the power minus 1. This enclosed inside square bracket, or you can write hc minus 2 t minus 1. Which option is this? hc minus 2 t minus 1. I think it's option A. That's your answer. Okay. In the next session, we're going to learn about dimensional analysis.